from the American International School, Johannesburg, and Jeff and I are doing the South Africa tap water part of the project. So when we were doing the project, we looked at the specific heat capacity, boiling point, and the pH level of the water, and then we're going to compare that to the one of the group that did the water in Norway. And now Jeff will be first explaining to you the specific heat capacity.
So the first aspect of South African tap water that we looked at was the specific heat capacity. And so together with the school in Norway, we found a method using these two formulas. The first one involves using power and time. So we used a kettle that was 2,200 watts, and basically with the kettle it took 78.16 seconds to boil. And so by using this formula we found that Q is equal to 167.6. And after we did that, we plugged it into this formula, Q is equal to MC delta T. We rearranged the formula so that we could find C, and we plugged in our values. We used this Q value on the numerator, and for mass we used 0.4 because 400 milliliters of water weighs approximately 0.4 kilos. And delta T is change in temperature, and so the temperature changed by approximately 61 degrees Celsius. And so we plugged that onto the formula, and in the end we came out with that C equals 6.867 kilojoules per kilogram degree Celsius.
Another difference between the tap water in Joburg and in Norway is the boiling point. And so Johannesburg is 1,753 meters above sea level, which is approximately 2,000 meters. And so what we did is we took 400 milliliters of water and set it on a heating tray, and we waited until the water started to boil, and we had a thermometer inside the cup, and then when the water started to boil, the temperature was 92 degrees Celsius. So at sea level, the water should be heating up at 100 degrees Celsius, but because we're above sea level, it heated up a bit earlier.
Okay, so the next thing we tested in the South African tap water was pH levels. So the first thing we did was use conventional pH paper to test the levels, and we did the test 5 times, and basically what we got was a pH of 7. But we decided that it wasn't really accurate enough, so we decided to use a pH probe that was attached to a Pascal meter, and that gave us a more accurate reading up to 1 decimal point. So we used the probe, and over 5 trials again we got the average of 7.9. That was the pH level. This shows that the pH level of South African tap water is a bit more basic, especially compared to that in many other countries. As here in South Africa we have lots of chemicals and stuff that are used in order to filter the water. Yeah.
So in conclusion, after comparing Norway's tap water and South Africa's tap water, and looking at the 3 aspects of specific heat capacity, pH level, and boiling points, our figures were?
Yeah, so for specific heat capacity, we found that the specific heat capacity for tap water was equal to 6.867 kilojoules per kilogram in degrees Celsius. Also, the pH of our tap water, measured using a pH probe, was 7.9, which was quite basic compared to what distilled tap water is. And finally, we did boiling temperature, and over 5 trials we found that the boiling temperature for tap water in South Africa was approximately 92 degrees Celsius.
All of these figures were a little off from what our counterparts in Norway had, but they were all around the same number.
Yeah, and basically overall, we felt that the whole experiment worked really well, and Skype really helped us communicate. And we just want to say thanks to everyone in Norway for helping us with this project. Yeah.
So, thank you.
Tack.
Tack.